Are you already recording? Oh, okay.
Yeah, it's starting now.
Okay, as we said, today we'll be going through functional equations, and I'll just reiterate myself. Like the two key concepts you need to know in functional equations are injectivity and surjectivity. So, what is injectivity? So, what injectivity is trying to say is that if you have a a, a value that for example, a that a function can achieve, a unique x achieves that value. So fx1 equals to fx2 implies that x1 must be equals to x2. So it means that for every possible value that's can be attained by the function fx, only one x can attain that. Surjectivity, on the other hand, implies that the whole range can be attained by the function. So for every c, there exists an x such that fx is equals to c. So these are the two key concepts in functional equations. And other than that, there are just like three steps that you should take when you're doing functional equations. The first one is during carrying out your basic substitutions. For example, x equals to 0, y equals to 0, x equals to y, x equals to 1, etc. The second step is to try and exploit symmetry that you find. So for example, maybe the function pxy is like uh f x plus y is equals to 2x plus uh 2y plus like y fx. So clearly this is symmetric, right? So when you do pyx, it just becomes f x plus y equals to 2x plus y plus x fy. Correct. So what does this like? So by exploiting symmetry, we are able to get that y of x is equals to x fy. So this is how exploiting symmetry over here by flipping it helps us get new conditions for our functional equation. The last one is about exploiting involution. So as I was saying, when you get some wrapped functional equation, for like when you have like two f's in a row, right? What you can actually do is to add an additional f and see what happens. So what you can do is that now instead of applying the two f's outside, what you can do is uh apply the ff here. So you replace x with fx, right? Because it's technically f of like this thing, which is fx, right? Should be equals to f x plus 1. So this condition basically just gives us that fx plus 1 is equals to fx plus 1. So that's how you use exploit involutions. So whenever you have f of something equals to something, what you want to do is that you want to add an additional f and you apply this condition on either these two or these two. And it'll give you two different results. But then the left hand side will be the same. Can you repeat exploiting? Oh, these are called involutions. So okay, I'll give you an example, which is of an involution, which is that f of x is equals to x plus 1. So what an involution wants you to do is to try and make it 3 instead of 2. So we have f x. So there's two ways we can get f x. The first way is you put a function on the whole thing, which will give you f x plus 1. The second way is you substitute x with fx. So what happens if you substitute x with fx over here? It becomes f fx is equals to fx plus 1, right? Because you're replacing x with fx. But in the first case here, all we're doing is we are wrapping the whole big thing with a function. Uh, okay, so you think of the evolution as finding two ways to. So if we have three f's and an x, right? There's two ways for us to apply the FF condition. So the idea of a triple involution is that you want to find two different ways to apply the same thing while keeping the left-hand side the same. So this will give us that this is equal to this, right? Which is quite useful. So that's the idea of a triple involution. Yeah. So these are like the basic ideas that you need in functional equations. And with these steps and two main ideas, you should be able to solve like majority of functional equation problems. So I can move on to now going to the first problem. So let's see. The first question. Okay, the first question is find all functions from the real to real domain such that x plus y f x minus fy is equals to x minus y f x plus y. Does anyone have any suggestions on how we should proceed with this question? You guys can just give like suggestions on what we should try. Try to show f0 is equals to 0. Okay. Firstly, the first step should be to guess the solution. So what do you think fx is equals to? Like a guess. What do you guess this to be? Fx is equals to kx. Kx squared. Okay. So we have fx is equals to kx. We have fx is equals to kx squared. Let's see whether or not your guesses are correct. So let's try substituting kx first. When we substitute kx, what do we get? X plus y times k x minus y is equals to x minus y k x plus y. So it works, correct. What about kx squared? We got x plus y k x squared minus y squared equals to x minus y k x plus y squared. But this is correct since this is just x minus y times x plus y. Yeah. But what about fx is equals to ax squared plus bx? Does this work? What do you guys think? This actually works because you see x plus y, a x squared minus y squared plus b x minus y goes to x minus y, a x plus y squared plus b x plus y. And when we factorize x minus y out, we get this. Which is obviously true. So the solution set that we should be aiming for is this. So this should be a correct solution set. So now that we've guessed the solution, what are some substitutions that we should make? Does anyone have suggestions on what subs we should make? I can just type in the chat like, what do you think we should substitute for x and y? X0. Um, okay. So x0 gives us. Yeah, let me just erase the guess portion because we don't need that anymore. Okay, so let's try what I am suggested. So px0 gives us x fx minus f0 is equals to x fx, correct? And that gives us that x f0 is equals to 0. Then now if you just simply choose like any x, right? It implies that f0 is equal to 0. Yep. So we have f0 equals 0 as I have suggested, which is like very helpful. What sub do you think we should try after this? Uh fa equals to fb. But how do you know that it is not injective? We substitute fa and fb and see whether it's injective. Okay. We can try what I am suggested also. So maybe we try um uh choose AB such that FA equals to FB. Now what would I give you? That just gives you that FA plus B is equal to 0, right? But is that really helpful? Like I don't think it's very helpful, so maybe not this idea. Someone suggested x y minus x. Uh Yeah. So, but what's wrong with fa plus b being equal to 0? Okay. I think you guys have some sort of idea, but then I'll just proceed with like the most intuitive solution first. So the next step is trying this. Substituting x over 2 minus 1 and x over 2 plus 1. So what does this give you? This gives us p, sorry, this gives us x f x over 2 minus 1 minus f x over 2 plus 1 is equals to minus 2 f x, correct? So f x over 2 minus 1 minus f x over 2 plus 1 is equals to minus 2 over x fx. Then next we substitute p x over 2 plus 1 minus x over 2. Then this gives us f x over 2 plus 1 minus f minus x over 2 equals to x plus 1 f1. The last substitution that we make is p minus x over 2, x over 2 minus 1. Then this gives us f minus x over 2 minus f x over 2 minus 1 to give us x minus 1 f minus 1. So when we add these three, right? When we add them up, we just get fx is equals to f1 plus f minus 1 divided by 2 x squared plus f1 minus f minus 1 divided by 2 x. And the motivation for wanting to proceed by such like steps and making such substitutions is because firstly, uh you want to find a way to get x as a sum and like a constant as another thing, right? So you're motivated to put like x over 2 plus some constant, x over 2 minus some constant. Then after that, you want to find a way to like find some sort of like summation where the left hand side cancels out and you're just left with the fx top. And that's why you proceed with statements 2 and 3. Yeah. Hmm. Does anyone have any questions about this solution? And there are people saying that, oh, we should try to show that the function is like injective, right? But then the problem is the function is not injective. Because like do you guys remember what we guessed the solution set to be? We guessed it to be our guess for the solution set was uh ax squared plus bx, right? this is clearly not an injective function, right? Because um x equals to 0 and x equals to um minus uh wait, let me see. Minus b over a, correct? Like f0 will be equals to f minus b over a1, which contradicts the uh like what do you call that? Injectivity condition. To want to so that's why it's very important to guess the solution before you proceed. Substitute x 1 minus x, then put x equals 1. Wait, we can try what John is suggesting. X 1 minus x, okay, let's see. P x 1 minus x will give you fx minus f1 minus x equals to, what do you have? Uh, 2x minus 1 f1, correct? Then put x equals to 1 minus x in the output function. Wait, what do you mean by put x equals to 1 minus x in the output function? So you want to do this? Then what do you have? We just get back the same thing, right? Like you won't get anything different. Maybe you can try working on your idea, and if you get something meaningful, you can maybe send it on the Discord later. Okay, I'll move on to problem 2. Uh, so problem 1 was the main takeaway from problem 1 was firstly guessing the solution beforehand and deciding what you should do after you guess the solution. So let's move on to problem 2, which is find all functions which are integers such that f minus fx minus fy equals to 1 minus x minus y. So does anyone have any ideas on what we should do for this? Y equals to minus x. Okay. Uh sure. Let's just try that then. Py equals to minus x. So x minus x, right? What would that give us? That'll give us f of minus f x minus f minus x equals to 1. So how would you proceed with this information? I don't think this is very meaningful because we don't really get much like information from this. But okay. So let's firstly try and guess the solution. What do you guys think the solution will be? Like, what's your guess of the solution set? Uh, y equals to 2x. Do you try substituting it? Does it work? Does y equals to 2x work? If y equals to 2x, we have what? Uh, f of minus 2x minus 2y equals to 1 minus x plus. Like, obviously, this won't work, right? So, if you actually try, the solution select to the function should be fx equals to x minus 1. Uh, you guys should try showing that like this actually like works. So, okay, I'll just go through the solution then. So the idea for this is uh, we firstly try substituting this p of f minus f f y minus fx minus fy. Sorry, fx comma y. So this will substituting this as x will give us f of minus f minus fy minus fx equals minus fy is equals to 1 minus fy minus fx minus y. Oh wait, sorry, I put an extra f here. So what does this give us? This gives us that the original equation is uh this, right? So this implies that f of minus 1 minus fy minus x minus fy is equals to fx plus 1 plus f of fy minus y. So fy plus x minus 1 minus fy is equals to fx plus 1 plus fy minus y. Then this gives us that f of x minus 1 is equals to fx plus 1 plus fy minus y. So if we fix x and we vary y over all the integers, this means that this must be a constant, right? Since if we fix, since this is independent of this. Like we can set x to be a constant. Then it means that f y minus y must be a constant. Which also means that fx minus 1 equals to fx plus a constant, right? Which means that fx is linear, i.e. fx is equals to ax plus b for some constants a and b. So now we are left to find out what a and b are, right? So we just substituted back into the original functional equation. And we just get f of minus a x plus y minus 2b is equals to y minus x minus y. Then we have minus a square x plus y minus 2ab plus b is equals to 1 minus x minus y. So we know that a is equals to 1, and as a result, b is equals to minus 1. Yep. Do you guys have any questions about the solution? There's another way where you show injectivity first. So do you guys know how to show injectivity? The injectivity is quite easy to show because the original function is let me check the original function. The original function is f minus fx minus fy is equals to y minus x minus y, right? So if fa is equals to fb and a is not equals to b, right? Just sub p ay and just sub p by. Notice that f minus fa minus fy should be equals to f minus fb minus fy, right? But then the left hand side is y minus a minus y, and the right hand side for this is y minus b minus y, which is not equal. It's a contradiction. Hence, injective. And once you have the injectivity condition, you can finish using Cauchy's functional equation. But I wouldn't suggest using it until you know like the proof to it, I guess. But okay, so another solution is that once you get injective, we have the original functional equation, which is this, right? Now we substitute maybe p x plus y is 0. And what that does is it gives us f minus f x plus y plus, minus f0 equals to 1 minus x minus y, right? And these two are the same because the right hand side are both 1 minus x minus y. So what we'll get is that f minus fx minus fy is equals to f minus fx plus y minus f0. And using the injectivity criteria, we get that minus fx minus fy is equals to minus fx plus y minus f0. Hence, fx plus y plus f0 is equals to fx plus fy. But we know that they're all like constants, right? So if we set fx y equals to 1, fx plus 1 plus f0 is equals to fx plus f1, correct? So fx plus 1 is equals to fx plus f1 minus f0, which is fx plus c. Hence, fx is linear, which implies that fx is equals to ax plus b. And we finish using the same method. So maybe to some of you guys, this is a much like more intuitive solution. Actually, I'll suggest like you guys to have like this thought process when you're solving the problem. Yeah. So the idea should be, okay, is this injective, surjective? Oh, it is injective. Then how do I use a substitution that allows me to exploit the injective condition? So in this case, is to make the right hand side the same so that you can remove the f on the outside due to the injective condition. And then after that, you're like, oh, okay, this kind of looks linear, right? Because fx plus fy equals to fx plus y plus f0. So this kind of looks like it's linear. Plus, we have that it's from integer to integer, right? Oh, then how do I exploit it? Oh, maybe I substitute y equals to 1. Since the interval between integers are 1, right? Oh, then you realize that, oh, fx plus 1 is actually equals to fx plus some constant. Hence, fx is linear, and we're done. So that's the thought process that you should be having when you're solving a problem. And the other one is just like pure like substitution, but then there isn't much like motivation behind the substitutions other than like intuition that some stuff are gonna cancel out later on. So I'll suggest the bottom solution more than the top solution. Yeah. Does anyone else have any other questions? If there's no questions, then just proceed to the next problem. I think this will be the last problem I go through first, since I think that not many people have tried the set yet. Okay. So let's move on to problem 3. So it's functions from real to real, such that fx is times fy fx minus 1 is equals to x squared fx. Sorry, x squared fy minus fx. So, do you guys have any ideas as to what substitutions to make, for example? X 0, 0. Okay. So what does 0, 0 give you then? 0, 0 just gives you that f0, f minus 1 is equals to minus f0. Is that really helpful? Not really, right? So maybe not 0, 0. Okay. Uh, how about we guess the solutions first? What do you think the solution fx will be? Maybe fx equals to 0 for all x. Anything else? Yeah, fx equals to x. Okay, so we've identified that fx equals 0 is like a very trivial solution. So suppose uh, fx not equals to 0 for all x. Wait, sorry. Uh, so wait, suppose exists x such that fx is not equal to 0. So how to proceed after this? Um, you can try p0 y. What would that give us? That give us that f0 f minus 1 is equals to uh minus fx, correct? Yeah. And sorry. Uh it should be f y f0 minus 1 should be equals to uh f minus f0. Yeah. So that gives us that uh 1 1. Okay.
So can you not do like take f0 to the other side and take f0 common, and then
Sorry.
like either f0 equals 0 or fy f0 minus 1 minus plus 1 equals to 0. Can you not do that?
Oh, we can do that, but um I think it might like overcomplicate things. So no, like the plus 1 equals 0 is like kind of overcomplicating the like whole thing. I think that's an easier way to find f equals 0. So wait, you can try p11 first, right? So that will just give you f1 f f1 minus 1 is equals to f1 minus f1, correct? So now your uh right hand side is equals to 0, and we have f1 f of f1 minus 1 is equals to 0. So uh hence we know that there exists a constant c such that fc is equals to 0, correct? Where c is equals to like f1 minus 1. So now what we do is we do p of c comma 0. So we know that fc is 0, right? So the whole of left hand side is just 0. So we have 0 equals to c square f0 minus fc, which is equals to 0. So c square f0. So it means that either uh, c equals to 0 or f0 is equals 0. But then even if c is 0, this just implies that f0 is equals 0. Hence, f0 is equals to 0. Correct? Do you guys agree? Do you guys have any questions about this? Uh, do you guys follow the why c equals 0 implies f0 equals 0? Because we said that the definition of c is that fc equals 0. So if fc is equals 0 and c is equals 0, it means that fc equals 0, right? Yeah. So now we can substitute x0. So what happens if we do that? Px0 give us fx f minus 1 is equals to minus fx. Then since we're supposing that not all fx is equals 0, it means that f minus 1 is equals to minus 1. Correct? So now we substitute minus 1 minus y. What does that give us? That gives us f minus 1 f y minus 1 is equals to f minus y minus f minus 1. So minus f y minus 1 is equals to f minus y plus 1. Correct? So now we have that f of y minus 1 is equals to minus f minus y minus 1. Do you guys agree? Like, is anyone lost right now? So, in other words, fx times y fx minus 1 is just equals to fx times minus f y minus f minus y fx minus 1. And this is equals to x squared fy minus fx. So the minus fx cancels out, and we just have that minus fx f minus y fx is equals to x squared fy. Correct? So if there existed some d is such that fd equals to 0, we just substitute p dy into this, and what do we get? We just get 0 is equals to d squared fy, right? But then since we're assuming that uh there must exist some x such that fx is not equal to 0, it means that d is equal to 0. Hence, fc equals to 0 implies that c is equal to 0. So only 0 can give you that uh like f of that is equals to 0. So basically, if d is not equal to 0, f d is not equal to 0. So now what we try is we substitute p of x. So what does this give you? So p of xx will give you that fx times uh f minus x fx is equals to minus x squared fx from this, correct? So now you can divide by fx since uh fx is not 0 for all x. And we get that f minus x fx is equals to minus x squared. So we know that um like uh for all non-positive real numbers, they are in the range of fx. So it's like surjective within like negative reals. Since you can achieve all other numbers. So also this kind of gives us like a fake uh injectivity condition, because if we have p a so if you have fa equals fb, just notice that um f of minus a fa is equals to minus a squared, and f of minus b fb is equals to minus b squared. So um note that like a squared must be equals to uh b squared. So we have that a is plus minus b, but this is not very important yet. We need to take this information into note. But then it's just good to know, like at this instance, that we have some sort of like injectivity going on. So from here, if FA is equals to FB, it must imply that A is equals to plus minus B. Do you guys all agree with this? I think it's more direct from here. So the assertion that minus fx f minus y fx is equals to x squared fy. Do you guys agree that from this must be true? Because we substitute compare minus f a f minus y f a is equals to a squared fy versus minus f b f minus y f b is equals to a squared b squared fy. So clearly the left hand side is the same, so the right hand side must be the same. So a squared is equals to b squared. So you have this condition. So what happens if FA is equals to f of minus a then. We will get that f of a minus 1 is equals to minus f of minus a minus 1 from over here. And this will give us minus f a minus 1, right? So f a minus 1 plus f a is equals to minus 1. Do you guys agree? Which would then imply that f of a minus 1 is equals to f of minus a minus 1, which implies that a minus 1 is equals to plus minus minus a minus 1, which is a contradiction. Hence, fx is injective. Is anyone lost right now? Okay. Uh, we'll proceed over here. So now that we have that, the injective condition, we can go back to our original pxx, which will give us that f of minus x fx is equals to minus x squared. And then f of minus x fx is equals to f of x f minus x, which is equals to minus x squared, right? By simply just substituting x equals to minus x. So this gives us that minus x fx is equals to x f minus x, correct? So fx equals to minus f minus x. But then since we have that since we know uh like all uh negative real is achievable, and we know this condition, it means that f of x fx is equals to x squared, right? And this reaches all non-negative real. Hence, f is surjective. Do you guys agree? So, what we have done is basically we've reduced it to f of x f y fx is equals to x squared fy. So now we just take p x1 and it will give us fx fx f fx is equals to x squared f1, which is equals to minus x squared f minus 1. And as we've shown earlier, f minus 1 is minus 1, which is equals to x squared. So we have established that fx times fx is equals to x squared. So we have that fx fy fx is equals to fx times fx fy, which implies that fyfx is equals to fx fy for all x that's not 0. Which then implies that fyfx yeah. So wait, sorry. So this effectively implies that we have that since fx is surjective, fx is also multiplicative. So now we substitute px y plus 1 and we subtract it from p of xy, and it'll give us that fx multiplied by fyfx plus fx minus f of yfx is equals to x squared, which is equals to fx times f of fx, which is basically equivalent to saying fyfx plus fx minus f of yfx is equals to f of fx, which basically implies that f of some other constant c plus a minus fc is equals to fa. So fc plus a is equals to fc plus fa, which implies that f is additive. So fx equals to ax plus b, linear. And if you substitute it back into our original equation, we'll get that fx is equals to x. So I think the solution is like a bit longer, but the idea to reach fx is equals to, sorry, the idea to reach fx times ffx is equals to x squared is a bit intuitive, and it's not that hard to reach the part that f minus 1 is equals to minus 1. So what this question teaches you to do is to really like work through the small nitty-gritty like details and then like reaching like a conclusion from there. It's quite a difficult functional equation, and it requires you to like really follow like the key ideas that I talked to you about, which is trying to show injectivity, then trying to show surjectivity, and from there onwards, making small substitutions that lead you towards the answer. Yeah. Do you guys have any questions about it? If you have any questions about the solution, just feel free to ask. Yeah, sure, sure. If you guys don't have any other questions, then I think that's it for today. If you guys try question 4 and question 5 and you need like any clarification about the solution, just feel free to ping me on Discord. Yeah. If not, I think that's all for today. Yeah.